Okay, so number one, how would we factor that? So some of the stuff that we did last semester is coming back. Factor comes up over and over again.
N to the third.
N cubed. Very good. Why n to the third? So we want to take a look at. So n to the third is the only exponent, n to the third, that we can take out of all of them. So notice your last one here is n to the third. The last term has an n to the third on it. If it's in standard form, that will be the case, but it's not always, but this one is in standard form. So we factor out the n to the third. Factor up there. Tell us what we get when we factor out the n to the third. Distance group. You did that part. Somebody else do the.
What's the question?
What do we get when we factor out the n to the third?
N squared.
Good.
Plus n on its own, correct?
No.
One times what? N. Good.
And then is it n? Oh.
12.
Oh. And 12.
And then just 12. Does that make sense?
Yeah, makes sense.
Questions on that? There's another part to it. Okay, so are we done factoring?
No.
No. Inside there can factor again. It's a quadratic. How do we factor that?
X.
Yes. So what multiplies to 12? It adds to 8. So we can't do the x method because that works only if an exponent
That's a good question.
a quadratic. And there's going to be some others where there's a certain type of look that's going to use that. Okay. So what multiplies to 12 that adds to 8?
6 and 2.
Yes. So n to the third times n plus 6 times n plus 2. And that's your answer. Okay, number 2. What's our greatest common factor in number 2? Okay. K squared. So what are we left with when we take out k squared here? This group. You did. That's valid.
That's valid.
K squared times what is k to the fourth? K squared. Keep going.
Plus
3K.
minus 18.
Minus 18. Okay, questions on that? Because we've got 2 parts again on this one. So now we can factor again. We're going to look at what multiplies to negative 18. 6 and negative 3. So k squared times k plus 6 times k minus 3. Okay, one more. Do we have a greatest common factor on number 3? N, that's right. What's left, this group here, when we factor out the n?
N squared minus 3.
N squared minus 9. We can factor this one again, but it's not a trinomial.
Yep.
How do we factor it when it's n squared
Perfect
minus
square.
9?
Oh, we use 2.
Going to be 2 factors. Can we take the square root of 9?
Yeah. Yes,
Now, what is it?
3 and 3.
3.
Oh, negative 3 and positive 3.
And then what's the square root of n squared? n, so n plus 3, n minus 3. So difference of two squares when you have a square minus a square. Okay, go ahead and do the U try, please.
Oh, yeah. Actually, they're on my side. Yeah.
It might have been just really.
Yeah, I'm just having trouble there.
I know. Every cigarette just want to take 30 minutes. Every cigarette you smoke takes 30 seconds. No, 30 minutes. Fast Diana. But die doing what I want and live doing what I don't want to do. That's 300 minutes.
Well, even is that even proven? I don't understand.
Okay,
It's just not like
your answer. Everybody check that out. Any questions before we move on to the next one? Hey. Okay, so what's our greatest common factor on this one, number 5? Some of you got it right away. 4k to the 4th, because there's a number that goes into all of these. So 2 would go in here, but we want the highest number. Yeah. So 4k to the 4th. So back here, this goes back here. Tell me what's left when we factor out the 4k to the 4th. And the rest of you sit quietly, please. Thank you. Good. So now are we going to factor again? Can we factor again on this one?
Yes.
Yes, it's going to be a little bit different though. When we go to make our x, what goes up on the top? 5 times 2 or 10. So because of that has a coefficient other than 1, we multiply the 5 times 2. So now what multiplies to 10 that adds to 7? 5 and 2. So 4k to the 4th times k plus 5 times k plus 2. That's our answer.
Was he just multiply the 5 by the 2?
Oh, no, we're not done, are we?
Okay.
Sorry.
Oh, you have to divide by 4.
Good. You have to, not by 4, but by 5. So let's explain. Let's talk about why. We took 5 times 2, which gives us 10. It makes our x work. But if we multiplied 5 times 2 here, it doesn't get us back up here. So if we multiply this out, it doesn't get us back here. So we have to divide this 5 out. So we get 4k to the 4th times k plus 1. And then what do we do with the 5? We slide it in front of the k, 5k plus 2. Okay, so what's the greatest common factor on number 6?
6x. 6x.
6 doesn't.
I'm thinking 7.
That's okay. 3x squared. So this group over here, tell us what's left inside the parentheses. Take out 3x squared. Good, 5x squared. And the calculator would be nice on this one, huh? So you're taking negative 93 and dividing it by 3. Yep, negative 31x, right? And then plus 30. So when we make our x, what goes on the top? 150. 5 times 30 or 150. What multiplies to 150? That adds to negative 31. This one takes a little bit of time. You're using a calculator and just trying some numbers that you know goes into go into 50. What's that? Good. 25 and 6. What are the signs on the 25 and 6?
Negative 6 per.
Negative 6.
Yep, both negatives. So your thinking should be on that. You know that 5 and 30 go in there. 5 is not going to work because 5 and 30 won't work. So think about a number that goes into 30. So 6 is a number that goes into 30. That's just a possible way. So now we get 3x squared, x minus 6, x minus 25. What next? Divide. Divide by 5. So 3x squared times 5x minus 6 times x minus 5. Okay, number 7. What's my greatest common factor on number 7? This group in the far back.
Maybe 6x.
Good. What are we left with? X squared minus 1. Can we factor that x squared minus 1 again?
Yeah.
Yeah, what does it factor to? X minus 1, x plus 1. Go ahead and do the U try, please.
I'll try.
Try.
Obviously, yeah. You get some more. Let's go.